Let's do a little helper on one of the chapter 5.4 homework questions. It has this integral. This function, 6,000 minus 4,000 cosine t, could describe the amount of traffic on a freeway in cars per hour as a function of time. The units aren't quite right. It should have like a frequency term to make it 0 to 24, but we won't learn how to handle that situation until a later chapter, U substitution. So for now, it's a little bit abstract, but it's still good practice. The first thing I would do is graph this. It takes a little bit of doing. So the x range of interest is obviously 0 to 2 pi. What's the y range? You have to zoom out enough to be able to see it. It starts at 2,000. When t is 0, cosine is 1. So you get 6,000 minus 4,000 times 1, which is 2,000. And then it's an upside down cosine like that. And its peak here is at pi, and the cosine of pi is -1, and you get 10,000. Right, so we want the area under that curve. The first things I would do would be to say, what's a lower bound? Well, obviously the area under this curve has to be positive, so a quick lower bound is 0. A better lower bound, we could say, let's draw a box of height 2,000. So height 2,000 and width of 2 pi minus 0. Then we can do an upper bound. That would have a height of 10,000. So it would be 10,000 times 2 pi minus 0. And then the guess would be halfway between 2,000 and 10,000. And what's halfway between 2,000 and 10,000? It would be 6,000. Coincidence? Probably not. All right, so having established all that, we can actually go about this in two ways now. We could split the integrand into two pieces, or we could do it all as one piece. I actually like doing it all as one piece because then you get a single antiderivative function to plot, but let's try it both ways. So let's try it without splitting. So let me just copy the integral here. What's the integral of 6,000? That's 6,000 t. What's the integral of 4,000 cosine t? Well, we can copy the 4,000. That's a constant vertical multiplier. Integral of cosine is sine or negative sine? Let's think about that. Derivative of sine is cosine, so that would be going backwards. So we can just put a sine t here. And just do that from 0 to 2 pi. So you get 6,000 times 2 pi minus 4,000 sine 2 pi minus 6,000 times 0 minus 4,000 times sine 0, all like that. I guess I didn't even need the big brackets because I've already plugged in the 0 and the 2 pi. So we're getting 6,000 times 2 pi, 4,000, sine of 2 pi is 0. So that term is all 0. 6,000 times 0 is 0. Sine of 0 is 0. So we're getting all that. So just 6,000 times 2 pi. Which is perhaps coincidentally exactly equal to our guess and definitely between our upper and lower bounds. So we'll say lower bound check, upper bound check, guess check exact, which kind of makes sense if you think about what area got included and what area didn't get included. All right, let's try it again by splitting. So we could say it's equal to the integral 0 to 2 pi 6,000 dt minus the integral 0 to 2 pi 4,000 cosine t dt. which gives you 6,000 t from 0 to 2 pi minus, you could move the 4,000 out if you want, 4,000 sine t from 0 to 2 pi, which gives you 6,000 times 2 pi minus 6,000 times 0 minus 4,000 sine 2 pi minus sine of 0, which is 6,000 times 2 pi minus 0 minus 4,000 times 0 minus 0. So altogether 6,000 times 2 pi, which checks out with our previous work. So how would you do this in Desmos, for example, if you didn't want to do all this plugging in? What I would do, I'd say f of t equals 6,000 minus 4,000 cosine t. And I'd say capital F of t equals 6,000 t minus 4,000 sine t. And then I'd say big F prime. And there you'd like to use t, but it won't know what to plot unless you use x, just to check that these two should overlap. Exactly. And then the actual answer to your integral you could say big F of 2 pi minus big F of 0, and it will do all the plugging in for you. And because it also has an integral feature, you could say integral 0 to 2 pi little f of t dt, and you should get the same thing either way.